All right, continuing on, this is still section 6.4. We're now going to look at another special product. This one is called the difference of two squares. So characteristics, difference of two squares. Each of these is going to have two terms. There is going to be a minus in the middle. That's where the word difference comes from. And the terms are going to have coefficients that are perfect squares. The exponents on the variables are going to be even. So a quick review, back in chapter 5, we did FOIL with something like this. We did first times first, then we did outside, then we did inside, and then we did last times last. So you notice here in the middle that these two are the exact same coefficients except they have opposite signs. So they add up to 0, and we come up with something that's the difference of two squares. Two terms, minus in the middle. 1 and 81 are both perfect squares, and the exponent is an even exponent. So as with the others, we're going to start in this chapter, in this section, with the answer, with the difference of two squares, and we're going to see how to factor it. So I'm going to do just a few examples down here. You notice that the first one is x squared minus 16, so I'm checking characteristics. It has two terms. It has a minus in the middle. It has a perfect square 16 here, and a perfect square 1 there, and it has an even exponent. So these are pretty easy to factor. You put down the double parentheses again, split up the 1x squared into x and x in each parentheses. Take the square root of 16, and now how do we determine the signs? Well, obviously we only want two terms here if we multiply this back together. And if you look back up here, you'll notice that the two signs were different inside the parentheses, which caused these two terms to add up to 0. So on this difference of two squares, what you want to do is put a positive sign in one parentheses and a negative sign in the other. Notice that I cannot put those in a single parentheses and square that because these are not the same parentheses. They have different signs. All right, so skipping over here to this 81x squared minus 4. Again, I'm checking characteristics. Perfect square 81, perfect square 4, minus in the middle, two terms, even exponent. So let me give it a shot here. Let's see what happens. All right, so now I'm working with 81x squared. So in your mind, you should be thinking of the square root of 81, which of course is 9. Take that x squared and split it up, 1x in each parentheses, and then think about the square root of 4. Put that in each of the second positions, and again, because we want the middle terms to drop out, we put a plus in one parentheses and a minus in the other parentheses. We also need opposite signs there so that we get this negative on this 4 right here. So you have to have a positive 2 multiplied by a negative 2 to produce that negative 4. All right, so coming down to this 16a squared minus 49b squared, this one has two variables in it. And again, I'm running through my characteristics. I see two terms. I see minus in the middle. I see a perfect square 16, a perfect square 49. I see even exponents. And so I'm ready. I think I have diagnosed that this is the difference of two squares. I've looked at all the characteristics. I'm taking the square root of 16 and putting 4 here. I'm taking the a squared, separating it out, putting an a in each parentheses. I'm taking the square root of 49, putting a 7 in here, and then I'm looking at this b squared, looking at this b squared and separating it out so that there is a b in each set of parentheses. So finally, I need to determine the sign, and because I want the middle terms to drop out, I put a plus in one and a minus in the other. So we're finished. The next one, z squared minus 9/16. Again, I'm checking characteristics. I see two terms. I see an even exponent there. I see perfect square 1, perfect square 9, perfect square 16, minus in the middle. It fits all my characteristics. It must be the difference of two squares. So I separate the z squared into z to the first, z to the first. I take the square root of 9/16, which is the square root of 9 over the square root of 16. Ooh, I ran out of space out there, which is 3/4. So this one has a fraction in it. That's okay. And again, because I want the two middle terms to drop out, I put a plus in one set of parentheses and a minus in the other set of parentheses. So that is your difference of two squares. I want to show you one common mistake that students sometimes make. These are all looking like difference of two squares, but the problem is they are not differences. They are sums. And when you see the sum of two squares, they are always prime, which means they cannot be factored. So if you're tempted to factor this one, y in the first, y in the second, square root of 100, square root of 100, what happens if you make them both positive? When you multiply it back together, first, outer, inner, last, these don't add up to 0 if you make both signs the same. You end up with this 20y in the middle. Well, you say, what if I made them both negative? Well, that might work. Let's try that. The only thing that does is it turns these into negative 10y's, and both of them are negative, so they still add up to this negative 20 in the middle. So you say, well, what if I make one plus and one minus? Okay, so first times first is y squared. Outer is negative 10y. Inner is positive 10y. Last times last is negative 100. So these nicely disappear, which is what we wanted. But look at the sign on the 100. It turns out to be a negative 100, and we were looking for that positive. So these are all prime. When you see the sum of two squares, you just say non-factorable or prime for those.